Here are quiz 4 solutions for Math 243. Let's see, we're asked to calculate the least squared regression line. So this y hat equals b1x plus b0 for the explanatory variable x and the response variable y. Okay, that's good. We want our explanatory to be x and our response to be y. Then everything follows these formulas that I wrote down here. So I didn't try to trip you up there. Anyway, so basically what we have to do is know these formulas. Know that b1 is r times the standard deviation of y over the standard deviation of x. So we could say that b1 is equal to r is 0.5, and multiply that by the standard deviation of y is 60, divided by the standard deviation of x is 3. So that is 0.5 times 20, in other words, half of 20, or 10. Then we could figure out b0 just using this formula right here. b0 is the sample mean for y, which is 400, minus b1, which we just calculated was 10, times the sample mean of x, which is 10. So we got 400 minus 10 times 10 is 100, which equals 300. So what we get is that our least squared regression line is y hat equals b1x, so 10x, plus b0, which is 300. So this right here is our solution to question 1. Question 2, using your answer to question 1, calculate the residual of this observation. Okay, so what this is saying right here is that we have an observation, and when the x value is 5, the y value is 330. So our residual is y minus y bar, so it's 300 minus y bar. So we just have to figure out what y bar is. Well, let's see, in part A we figured out y bar is 10x plus 300. So when x equals 5, we got 10 times 5 plus 300, which is 350. So our residual is 300 minus 350, which is negative 50. And that's the answer to number 2. All right, finally, number 3. Decide which residual plot best fits each statement below. Okay, so we got residual plot A here and residual plot B here. And these were examples of two things we discussed in class. One of them is called heteroscedasticity. So what heteroscedasticity is that when your x value gets bigger, your residuals get bigger. That is, the variance is not, sorry, I didn't say that right. When your x value gets bigger, the variance in your residuals gets bigger. The x values are more spread out. So you get this kind of shape going on here. So I don't know, heteroscedasticity by definition is what we got here in residual plot B. So for A, we'll say it's plot B. And pattern residuals is the other thing that can go wrong. Pattern residual is when there's some sort of a pattern with your residuals. So here's the residuals. It kind of looks like we have this, like an upside down U-shaped pattern here. So pattern residuals is plot A. Indicates nonlinear regression may be appropriate. Okay, so the one thing I told you about pattern residuals is that they indicate nonlinear regression may be appropriate. So kind of just the definition here, this goes with plot A, and has limited prediction value for large values of the explanatory variable. I think I said that's the problem that you get when you have heteroscedasticity. So this would be plot B. The idea here being when your explanatory variable is really large out here, the variance is so huge that you can't really use your least squared regression line to make a good prediction, because it'll tell you something, but the variance is huge, so the actual point isn't necessarily close to the least squared regression line. Anyways, that is the answer to number 3, and that is the end of the quiz.